feel like this is something of vital importance. I think there's a big disconnect between what the intelligence communities are privy to and what information hopefully they have. I would assume they do. I hope they just hoover it all up, but consider it my own personal service. And I guess, hey, I tried to join, couldn't have a gun. Stupid laws. Anyway, I think it would be a strategic national security interest to understand what's going on with the magnetic field. Ancillary, maybe just a Earth expansion, whatever, but it's definitely important. The helio sheet, there's so many, but there's a disconnect between, these guys, they're, the circles they run in, they're not running in the same circles. The science has gotten way ahead. The independent science has gotten way ahead. It should be no secret to anyone privy to any kind of academic journals who understand peer review process that at this point science has become a bit of a monopoly, and if COVID wasn't a wake up to that, science is bought and paid for. It's not supposed to be by committee. The results are supposed to speak for themselves. Merit based. It's the whole DEI, the whole spiel. But regardless, there is 100% absolutely a national security threat. If we're really undergoing a magnetic reversal, not a geographic pole shift, it's just a magnetic pole shift, but the weakening of the field, the recent auroral activity, given it was only a K, that I've seen higher KP indexes, I've seen more geomagnetic instability on stronger flares in the past that did not produce the kind of auroral events that we had. And then immediately the intensification of that hurricane, Beryl, whatever, everything adds up. The science is there. I just feel like someone's missing the interim, the glue, the conduit, the corpus callosum, so to speak, the in-between. Someone needs to explain to these people, and I think that could be me. Maybe how I serve my country, and I always wanted to be a Marine. My father was a Marine, but I do think it has very important geostrategic and actually national security implications. If the Carrington event set telegraph lines on fire, imagine what it would do to silicon diode resistors and all these little integrated circuit computer chips that we got. All this stuff. I don't know what the impedance would be. I don't know if it would reach like a critical level where everything would catch on fire. Maybe, I think what it probably had to do was the specific mass, or specific gravity, or because if you have a long wire, you're gonna have way more effect than if you just have like small circuits. So maybe not all of them, but certainly on the daylight side of the planet, if we were to have like an X50 or a Carrington level, not even with the magnetic field as weak as it is, we could have like a high M. It depending on where it hits, maybe over the South Pacific anomaly, where there's that giant gap in the magnetic field. But it is important, and I'm not so sure. Look, it's certainly not mainstream science, and it's certainly not even like your Michio Kaku's, your Neil deGrasse Tyson's, and your Bill Nye, the mechanical engineering guy who has no idea what's going on. These figurehead, these people, these Anthony Fauci's. Science is not a consensus. Science speaks for itself. The data speaks for itself. Of course, the data has to be real. You can't put thermometers on tarmacs and next to air conditioners, and you should expect higher heat readings. But that notwithstanding, the far more potent and powerful driver of the climate and even inclement weather on this planet is the sun. And this realization, when you look at the CO2 they map using spectroscopy, they can determine which gases are where in the atmosphere. Very, very well. And that's the thing that kills me. It's always the patents that are always so well defined. The technology is always perfect. It's the interpretation, the interpolation or interpolation of the data that kills me, because what you'll see is that a lot of the CO2 gets eaten up every year. Trees breathe it in. Yeah, sure, don't cut down more. But I mean, come on, you got algae, there's so much on this planet that's species died out because there used to be more oxygen, you know? So just keep that in mind. But also remember, CO2 is plant food. So, and cyclically, if you look at ice core samples, going back from hundreds of thousands of years ago, we know that these are cycles. We know everything from the intermagnetic domains, which align when cooling magma, igneous rock, found at various depths and therefore traceable back to their date of origin, you know, because there's enough surrounding like carbon-based material where you can get a rough carbon. Even but when I'm saying rough carbon, I'm not talking like, you know, 10, 100. I'm talking within thousands of years, but still, the sig figs on that, the significant figures on the carbon dating within 100,000 or even within 10,000 years are just overwhelmingly accurate. And what you see is that the Earth's magnetic field has reversed several times. There have been cataclysms. There are fossils found at the highest points in North America. On the highest mountains, they find fossilized seashells. You know, floods are real. And not to say that this is this particular cycle, but what we can say definitively is that all of the planets in the solar system have recently undergone significant changes, whether be it their rotation, storm cycles, atmosphere, wind speed, atmospheric compositions, atmospheric densities. All of these things are changing rapidly at the same time that we're seeing a geomagnetic excursion and have lost data on. So, I mean, I don't know who or what percent of people are aware this is happening, or is that there's this impending, I won't even say doom. Look, 12,000 years. Look, there's cave drawings, we've lived through it. But we say 2,000. Who's to say what the time really was? But even if it is 12, then it's 24. You double it. You're looking, you know, 12. So 12 would be 600. That would be like, what's 600s? That's not the Dark Ages. No, Middle Ages were what? No, right around. Pretty damn close. And they have also, I'm thinking, no, that's way too far off. 12 would be like, yeah, no, that'd be like, no, 800. Yeah. That lines up perfectly. So that means it took about 400 years for Jesus, because then you figure from 800, you take 12 off, minus 400. And China's records go back farther, and in all these cave drawings, in all these depictions, there's always celestial bodies are not important for just no reason. I mean, there's a reason why all of these things are aligned. All of the ancient structures fit together with a damn razor blade, and they're all aligned to true north. And you could say, well, the precession and yeah, but that's like a 360,000 year cycle. Pyramids are only, what, now they're trying to say 4,000, so it'd still be within margin of error. I mean, 4,360, you figure that's like what? That's not even 1%, or it's just slightly over 1%, like 1.128654 whatever the hell it is. But it's still 1%. It's not going to be noticeable. So even for 4,000 years, you know, if that truly is the age of the pyramids. But the important thing is that when the field goes down, if the ideas are correct about primarily hydrogen ions escaping the sun, magnetic field being the buffer, barrier, the blockade, the deflector of these said particles, when you reach a hydroxy, and so you'll have hydroxyl because you're going to have OH. Because if the shield goes down, you're not just going to get the charged particles, you're also going to get electromagnetism. You're also it's going to electrify the skies. There's going to be more lightning. And actually, some of the biggest scars on the planets could be presumed to be, it's like when you rub your socks across the floor and touch a doorknob. Planets got a little too close, zap. That's not to say, I mean, the Grand Canyon could have been weather erosion. But if you hear some of the theories that Graham Hancock has, or I'm sorry, Randall Carlson, who also appeared with Graham Hancock, has very, uh, I would stick with Randall Carlson on this one, because these are geological, these are tried and true, tested methods of measuring amplitudes of waves, essentially. Because what you end up with is a rock structure where it's essentially it's undeniable. I mean, when you look at the amplitudes, they scale perfectly from, you know, like a, say, a trickle in a stream to a beach sand wave to, you know, a floodplain to an entire region. I mean, these things scale perfectly. Fluid densities, I mean, wind will behave differently, which is why sand dunes look different than water, but similar, because it's a fluid acting on a substrate. And it's pretty hard to deny. So there's some places where there's canyons that are just carved, and you're like, well, that would only be possible with a massive volume. You know, flow rates. One of the great, one of the incredible things once we got into the industrial age, after the age of science, and you know, when physics really got tamped down, Newton's laws, Einstein was helpful, not so much with the physical laws, but we have pretty much narrowed down our understanding of erosion. And the Sphinx at the pyramids, based on our knowledge, is so cacophonous. It's so asynchronous. It's the amount of time doesn't add up. There's just so many problems with that, you know? Because, first of all, even if it was semi-arid, let's say not even desert, those kind of rains, they would have to be tropical rains. And based on, you know, the observations by, well, I guess they're experts, so we're kind of just taking their word on it. But these are people who their whole lives have studied geology, and they say that this pattern of erosion is water erosion and could not take place at the current, you know, precipitative, climatic precipitation levels where Cairo currently exists. And so you think to yourself, well, you know, it used to be green. Well, it was, but what caused it and why, and why the shift? Well, you could say deforestation and man-made climate change and all that, or you could look at exactly where the South Pacific anomaly is, which is a giant hole in the magnetic field that exists right over Africa and the Sahara. So, I mean, it's so easy just to say, people did it. Sure, there's a billion, billions, multiple billions, but you start looking at the numbers, the greenhouse gases, you know, the number of termites that we kill every year probably far outweighs the amount of wood that would have been eaten by termites had we never even existed. The extermination of termites is insane, but the reason I bring that up is because methane is a 30 times more powerful greenhouse gas than carbon dioxide. Methane is more effective at trapping in those UVAs and the reflective radiation, the infrared and reflective radiation off of the surface of the planet. Whatever libido it had, or it doesn't use libido, the reflection of the actual light, but also the infrared reflection. So everything puts off like a heat signature, you know. And you know, like if you've ever seen like Predator, like you have a thermal heat signature, and your body radiates that out. It's not visible by the naked eye, but certain animals like pit vipers and certain, I think there's certain invertebrates that also can see an infrared. You know, like bats here, echolocation. Every animal uses a different sense, but infrared is actually a detectable signature. And in fact, there's certain substances, if you're trying to isolate, need to be shielded from the infrared for certain scientific, you know, procedures. But anyway, point being that methane being so much more powerful and humans mitigating termites just because of our development. See, had we never come here, they would have eaten the trees. But now that they're here, they go to the houses. It's cheaper, easier wood. It's actually tastier wood. It's drier wood. But we massively tin off houses and kill them off. We have reduced the termite population by expansion. But they also produce a gas which is 30 times. So then you say, well, methane. So you say, well, cows. Okay, well, fine. Well, one for the other, but at the end of the day, none of that is going to be even close, not even remotely as impactful to your life as the sun. You look at the solar cycles, you look at the Milankovitch cycles, you look at the north and the south, something very new just happened. Something we've never seen before. We're on the precipice of something, well, granted, the tools and, the ability to, the metrics, we didn't have the technology until, well, a lot of it, very recent, 100 years or so. But again, you go back to the core samples, you go back to magnetic domains, you can determine roughly what the magnetic field was, the direction, where it was, roughly the strength, by taking several samples all across the world, different latitudes, longitudes, and you can piece together the puzzle over time using markers that are key. There's certain layers that are going to be relatively consistent over continental land versus what you're going to find in, say, like, permafrost or tundra, but they're correlative or correlative, I think. And so it's pretty evident that what we're seeing now is something that, since we've had the actual metrics to measure, we've never seen, which is the northern and southern polarity of the sun changing in a weird way. So taken with all these other changes, it's actually quite shocking that the Earth has undergone far fewer changes. So that leads me to believe that maybe the smartest of the smart, the people you have that are, I used to think that there was like a super secretive genius, deep state CIA, but I'm starting to think maybe it's just compartmentalized, and maybe to its own detriment, not really integrative. You guys don't talk to each other about different things, and science has been so co-opted. So it's like you guys are the blind leading the blind. But I would like to shed a little light on something, and it's very important. It would seem as though the intergalactic Helios sheet is making its sweep. And as it does so, it kicks up a giant cluster F of interstellar dust, which we're seeing, and we're not sure why. But it would all be consistent with the intergalactic Helios sheet, which is sort of like, well, it's like any other wave, whether it be a microwave, radio wave, X-ray, gamma ray, whatever the wave, the amplitude, the frequency, they're all just waves. And within our solar system, we have the Helios sheet. Even the Earth itself puts out a Schumann resonance. It's its own natural frequency that the Earth vibrates at, given any particular, time of year, distance from the sun, apogee at the moon. There's all the factors change because it's all just mass. It's all just vibrations of just a giant pile of rocks and molten shit and water. So it's like a wine glass. It's gonna sing at its particular frequency, and then the Earth does that, and all the planets do as well. And whatever the natural frequency, whether it be a bridge, a string, or a wine glass, or a planet, that particular hum or whatever, sometimes it's a very complex vibration. It's not just one tone, there's so many, all the shit going on, but it's for a relatively consistent. And so we track these things. SETI, famously, the every 20-minute transmissions, probably a quasar, probably some kind of like distant, repeating nova or micronova, or like some gravitational collapse or something like, but it creates a consistent sound. So we know that these harmonics, these wave functions are changing. And we know this because we've been studying them since, I think, the early I want to say Greer was one of the first on SETI. That was back in the, what the hell was his name? Carl Sagan era, when we first started looking at all that stuff. But so it's like, are you guys just ignoring all this data? because I'm not tied into any kind of governmental organization. I'm not NASA. I'm not a scientist. I barely even went to college. But I'm aware that there are atmospheric, magnetic, auroral, storm changes on several planets right now. And it seems to be consistent with the weakening of the Earth's magnetic field. Now, one theory could be that the very dynamo that generates the magnetic field is a consumable resource. Now, that's not something a lot of people talk about, but every time we build any generator, motor car, power plant, even a phone, battery, anything, any magnets rubbing together on copper, it depletes, which normally would be inconsequential, but with the rate of growth and industrialization, and now there's like massive amounts of generators, is it a finite, usable, or should I say, not exhaustible, but perhaps diminishable product or commodity? Or, what I'm essentially saying is like bandwidth. Like, is the Earth only producing so much magnetic field and we're using it up in all our electronics? Which, if that were the case, would be horrific, because there's no solution. The only thing fueling the growth is the growth itself. The futures market of everything, whether it be money, oil, commodities, food. And this population collapse is not helping that, but it's pretty much all centered around the promise of growth funds the loans we take today to funnel money into special interest groups, hedge funds, lawyers, bankers, and rich people. But they're a necessary evil because they are the catalyst for, we promise we'll pay you back tomorrow kind of lifestyle. And we usually do with growth of population, of GDP, of everything gets more valuable over time. Things become more efficient, and usually, for the most part, if they would keep their damn hand out of it, the market would figure it out, and everything kind of, all the chips land and settle where they do, they settle. Things like to settle down. It's sort of like this weird system of balance between entropy and order. Like, the order is the natural distribution of resources as seen fit by the entropy of the market. So like the chaos creates order. I hope I don't have to really further elucidate. Oh, that makes sense. So we sort of live in that system, but in that system there's compartmentalization, roadblocks, and then there's also this like refusal to entertain ideas which are either contrary to ours for ideological reasons or social pressures, or for whatever reason, we're less apt to adopt ideas which are sort of out of the tribe, out of the clan. You don't want to be ostracized, and you don't want to be demonized, and you certainly don't want to seem like a crazy person. Ironically, in our large societies now, you would think that would be less important, but it's actually become more important. And so, I feel like there's almost like this paralysis people feel, where they don't want to take a radical move or act, especially tied into the way that our society works, where your mobility is relatively static with occasional horizontal and vertical movements, and God forbid you move down. Status, society, it's the way we function. It's where a lot of times we sort of substitute otherwise the feelings of meaning and belongingness. We sacrifice that, or we refuse to make the sacrifice to feel that, so that instead we feel a sense of status and importance, and it's like this ego fueled thing. But what I would say is this: if there's an existential threat to humanity, the people need to know. And if we have information about the current field strength of the Earth's magnetic field, our protective bubble that blocks all those charged particles and everything that's flying off the sun and cosmic rays as well, if it's weakening, we should know about it. And if there's more to the story, we should know about that too. But, as far as I can tell you right now, it seems like weaker and weaker events, coronal mass ejections, which otherwise would have just been hiccups and nothing. They would have been literally nothing. We had just brushed it off. Now they're causing record auroras, farther south than ever seen before. And of course, you could say, well, everyone's got a smartphone now. Well, fine. That's fine. But when no one had smartphones, where did they look? They were outside looking at the skies. The argument goes both ways. And besides, it's well documented. I mean, the Carrington event was well documented. And then there was a couple other events that weren't quite as big. I think in like the 70s. No, that was when it got cold. No. Well, I think there was the one in 2012 or 14. Bunch of stuff went, like a bunch of in the northern latitudes there were electrical disruptions, and I believe the FFA grounded all flights or something. That may have been due to concerns over like radiation exposure, or it may have been due to failures in some of the airline electronics being at high up. But those were far more powerful. This most recent one was so weak. No one expected it. Not even my trusted sources, who are typically on the more I would say analytical and conservative side when it comes to things like this. Like I would take my independent researchers who have been right consistently more often over the governmental, the NOAAs and the NASA's and the interesting thing is that the data is still coming from the same source. It's just the interpretation of the data that I have seen several, well, I can't really say several, at least two independent space weather sky watchers and otherwise magnetic field concerned people have much more accurate predictions about what will happen during these events where the KP index goes 4 to 5, 6 to 7 geomagnetic instability. And then my goal would be to either share what I know, which may be far less effective, but at least point people in the right direction. The people who need to hear this, they should be paying attention to this, because this has grave, I would say, interpretations or ramifications for national security, and for, especially when you consider the infrastructure, the military infrastructure, the electronic systems that they have. For our own national defense, we need to consider hardening almost all of our military hardware, God, if possible, or at least have a significant auxiliary, something in a Faraday cage or buried somewhere where, God forbid something should happen like that. There's preparedness. If you can't retrofit the entire, military industrial infrastructure, then at least have strategic, stockpiles of equipment and tools and things that are shielded from that. Because that's a very serious threat. And as far as I know, and this is just, at this point, what I'm about to say is hearsay, but I have heard that Russia has hardened military equipment that is hardened because of national security, but also because a lot of that stuff is vacuum tube. They're not using silicone diode resistors. They're not using the capacitors that were used. They have old world technology that they never updated, and at some point they were going to, and their scientists were like, no, leave it hardened. Is it more expensive? Yes. Is it more virile? Does it have a better chance of surviving? Yes. So Well, that's about it.